So an experiment is performed in order to prove Archimedes' principle that states that the buoyant force or Archimedes' upthrust force depends on the density of the liquid. You can read the materials and the procedure in details. I am going to explain it by referring to the following documents. So in this part, we have a block suspended from a spring balance. The spring balance indicates in this case 10 Newton. What does this value represent with respect to the block? We know that the block being at equilibrium in this case is under the effect of two forces, which are the weight and the tension. So the real weight vector plus T vector equals 0 vector since the block is at equilibrium. So W real vector equal minus T vector. Then as a magnitude, the W real or the real weight is equal to tension. Why am I calling it real weight? Since the block in this case is placed in the air. Here there is a very important note. The spring balance directly measures the magnitude of the tension force in all cases. So the spring balance actually measures the tension force. However, in the case when an object is suspended from it, just like this case, we can say that it measures the real weight. Why? When the object is at equilibrium, since the real weight and the tension have the same magnitude. So it is measuring the tension. But we can say by reading 10 Newton that the 10 Newton here represent the real weight. Why? Since it is at equilibrium, and at equilibrium, upward force is equal to the is equal to the downward force. Now, this same object is placed in water, and the indication of the spring balance changes to 60 Newton. Now, this indication can no more be called the real weight, since the object is no more in the air, however, it is immersed in a liquid. Actually, this indication is called the apparent weight. Why? Let's see why. What are the forces acting on the block in this case when being immersed in water? It is the weight, the tension, and the upward force or buoyant force exerted by the liquid on the object. Since it is at equilibrium, then the sum of the vector forces is equal to 0. They cancel each other, keeping the block at equilibrium. Now, we put all the upward forces on one side and all the downward forces on the other side. While using the vector form, we still have to keep or to write a minus sign that shows the opposition and direction. So upward force vector plus tension force vector equal minus W real. But as a magnitude, the sum of magnitude of upward forces equal to the sum of magnitude of the downward forces. Yani upward and the tension are equal to the real weight. Everything that is pulling upwards the block is equal to everything pulling it downward. That's why it remains in its place. This equation means this thing. So T remains on this side. Bringing F upward to the other side, we get T is equal to real weight minus the upward force. So here, the object appears to be lighter, appears to be having an apparent weight equal to 6 Newton. Why? Since there is an upward force opposing the downward force, making the object appear lighter. Just as the case when you try to hold your friend in the pool and you find him or her to be lighter. Why? Due to the upward force that opposes the real weight, letting it appear to weigh less. So here as a comparison, the apparent weight, which is 6 Newton, is less than the real weight, which was 10 Newton when being suspended in air. As a conclusion, the object appears lighter when immersed in a liquid due to what? Due to the upward force, which is the Archimedes upward force. So apparent weight is always less than the real weight لأنه it is equal to real minus, and when we subtract, this means that we are decreasing the quantity.